Okay, so hello everyone, welcome. Can you hear me? Okay, can you hear me?
Hello, yes, we hear you. I'm hearing you.
Okay, thank you. Just we're waiting 1 minute for joining all of this other participants and we'll start. Okay, so in the meantime, I also give an announcement for our upcoming online training program, mainly Google Earth Engine. It mainly for the beginners to advanced level online training program. If you have no knowledge about that Google Earth Engine or JavaScript or Python, this course is only for you. I hope after completing this online training program, you are able to do any types of remote sensing analysis very quickly and efficiently using the Google Earth Engine platform. So mainly this class will be start from the 12th January. New batch will be start. Admission last 11th January and booking last 10th January. And first 10 registered people will get the 50% discount on this online training program. It's total 7 days online training program. Mainly class will be taken for the Friday and Saturday in a week. Class duration is day 3 hours, and this is the time about this class. And mainly this online training program, we are just focusing for the beginners who don't have any knowledge about the Google Earth Engine or who don't have any knowledge about the Python or JavaScript. So don't worry about that. You start from the stress and up to the advanced level after completing all of these classes. So here you can see I already added all of this course content for the first day, second day, then third day, fourth day, fifth day, sixth day, and seventh day. You can easily learn all of those things properly. You can easily learn all of those machine learning method in Google Earth Engine platform and how to perform the different types of machine learning method to develop the land use land cover classification map. A lot of things we try to cover in this online training program. And you will also get some benefit after joining this online training program. You can get the certificate, you can get all of this slide PDF, you can also get all of this practice code, you can also get the recorded video class if you miss any live training session. And you also get the lifetime teaching support. It's very important as a beginners. When you want to learn the Google Earth Engine platform, you face a lot of problem. Okay, so that's why you need the continuous support. So when you want to join this online training program, you can get the continuous support. After completing this total 7 days online training program, you can get the lifetime teaching support. So that's why you can easily learn all of these things smoothly, and you can easily learn the Google Earth Engine platform and develop your code for any types of remote sensing analysis. So if you want to join, simply contact in this WhatsApp number and also contact in this email. I already add all of those things in the video description. You can simply check it and then complete your registration as soon as possible to get the 50% discount on this online training program. Thank you. Okay, so hello everyone, welcome. So basically today is our 5th number of days. So basically today I try to discuss about that air quality monitoring, how we can easily make the air quality monitoring, different types of parameter such as nitrogen dioxide, sulfur dioxide, carbon monoxide, formaldehyde, methane. So these type of gases, how we can easily monitor, and a lot of things I do cover. Okay, so let's go simply share my screen. So now can you see my screen? Is it visible? Okay, I hope you can see my screen. Okay, so let's go. So first of all, You can see the course content for the today's session. So today I talk about the air quality monitoring, mainly all parameters which are available in the Sentinel-5 satellite imagery, and how to download the air quality parameters time series data in Excel file or CSV file. So previous class we also try to discuss about that. We first of all we try to make a chart, and then from the chart we download the CSV file. Okay, but in this session I will show you that how we can directly download the time series data in CSV without creating any types of chart. Okay, so it is a benefit because sometime chart is not work. It show that it exists the memory limit. So that's why you also need to learn about that time series chart in CSV directly. Download the in CSV format. We also talk about the air quality monitoring time series chart. Okay, as well as air quality monitoring, how to calculate the total emission of any gases. So in this time, nitrogen dioxide, sulfur dioxide, or carbon monoxide, or methane. So any gases, how we can easily calculate the total emission. Okay, and we also talk about that ArcMap software. So mainly how we can easily make the research paper map using after downloading the TIFF format, and then how we can easily use the ArcMap software to create the research paper map for our research paper or presentation work. So basically, Google Earth Engine platform, we can only download the TIFF images. For the further processing of map, we have to use the ArcMap software or QGIS software for the research paper or the presentation work. Okay, so any kind of TIFF image we can easily do using the same approach. I hope you can easily do. So let's go simply slide. So here you can see the two types of map. One is that nitrogen dioxide and methane gas concentration map. So first of all, the first map is that methane concentration map of Kuwait, and this unit is the PPB. And also you can see this another map, nitrogen dioxide concentration map, year of 2020, month of January, and this unit is the mole per meter square. Okay, and in this time I download this TIFF images from the Google Earth Engine platform, and then further creation of map title or legend, also scale, north line, also grid. So these type of things we can do using the ArcMap software. So today's session I also show you that how we can easily make this type of map, as well as also you can see this is another map for the nitrogen dioxide level rebound for the different time period. So in this time we will also make the classification. Okay, so here you can see this color identify very low, then low, medium, high, very high. So this type of classification we can easily do using the ArcMap software. After downloading TIFF images, we can easily make this type of classification about that. So here you can see the before lockdown, during lockdown, post lockdown. So this type of scenario we can find out for that nitrogen dioxide level rebound in Bangladesh in the COVID situation. Okay, so we can also make the classification using the ArcMap software easily after downloading TIFF images. I'll show you that. Okay. So in this time, air quality monitoring. So mainly in this time, we are using here the Sentinel-5 satellite imagery. This Sentinel-5 satellite imagery is mainly access the different types of air quality parameters such as ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, methane, aerosol, carbon monoxide. So this type of gases we can easily access from this Sentinel-5 satellite imagery. And this is the link about this dataset. You can simply go to this link and you can easily access the Sentinel-5. Or if you want, you can simply open your code editor. From here, you can also go to the browse data catalog, and from here you can easily access the dataset of Sentinel-5. So you can see the search pleasant dataset. Simply click on here. You can see the browse data catalog. Okay, click on here. So now we can easily access all of those dataset from go to the Sentinel. And from this Sentinel, you find out that you can see Sentinel-5 tropospheric monitoring instrument. This dataset we can easily access using the dataset for that ozone, methane, formaldehyde, aerosol, carbon, nitrogen dioxide, sulfur dioxide. So all of those gases we can easily access from here and make the concentration map, as well as also calculate the total emission, also make the time series chart. Okay, and finally we can easily download the TIFF images. So in this time, suppose I want to work for that nitrogen dioxide. Okay, so all of those gas is the same process when you want to work. So I show you the nitrogen dioxide. So you also try to for the other gases such as carbon monoxide or formaldehyde or methane. Click on here. So now it opened the full data set of nitrogen dioxide. Basically, this data set is availability date is the year of 2018 06/28 from 2023 12 December. This time period we can get this data set globally, and data set provided is that European Union ES Copernicus, and this is the unique ID of this data set. And in this data set we also get some band. Here you can see the nitrogen column number density. So it's the one kind of band. It's provide the total vertical column of nitrogen dioxide. Mainly it's the calculated the ratio of the slant column density of nitrogen dioxide and the total air mass factor, and then create this band, and its unit is the mole per meter square. Okay, so it provides the density of nitrogen dioxide, as well as if you want to get the different types of atmosphere phase, tropospheric, stratospheric, tropopause pressure. So in this time you can see tropospheric, stratospheric level. If when you want to monitor the nitrogen dioxide, then you can also use the tropospheric, also stratospheric, this type of band you can also use. So in this time I make the density map. Okay, mainly it is the total vertical column of nitrogen dioxide. I want to use it, and you can see the unit is the mole per meter square. Okay, so when you want to use this dataset, first of all, this dataset you need to import in your code editor. So it's very easy process. We already know about that. Simply copy this snippet ID and paste in your code editor. Okay. So after you can put any variable name, Suppose I put the name is that NO2. Okay. So in this time here you can see I simply import the full image collection and store it in this variable NO2. And now this image collection has different types of band. But in this time, I want to work only for that specific band, nitrogen column number density. Simply copy this band name and then select this specific band. So just use here the select, okay, and put here. So now you can simply suppose, as well as this data set, suppose I need this data set for the specific boundary. Okay. So you can simply take here, suppose I simply import the boundary of suppose Dhaka. And now I want to just give this shapefile variable name, suppose RY. Okay, I need this data set only for the specific boundary for this Dhaka city. Just I simply use at the same filter bounds with RY, as well as I also need to filter this data set for the specific time period. So just use at the filter date and put it. Suppose I put here the year of 2023. Suppose December, 1st December from year of 2023. Suppose December. What is the last time? Time is that you can see the 12th December. So 12. So now I want to check how many images we can get between this time. For this, simply use at that print NO2 and use there the size function. So now it computing how many images are available for the study area of Dhaka city between the time period 1st December to the 12th December. Here we can find out 155 images. So this is my image collection. Okay. Now, if you want to make the time series chart, suppose I want to make the time series chart and then check between the time, suppose 1st December to 12th December, when or the density is the high and low, I want to check it from the time series chart. So for that, you can simply use the same function UI dot chart dot image dot series and put all of those things. You can see first argument is the image collection. Okay, how many images? In this time 155. It's already stored in a variable. What is the variable name? NO2. Click copy and paste here. Okay, region. In this time, what is your boundary? I want to make the time series chart for the Dhaka city, and Dhaka city is already stored in a variable ROI. Just put here the ROI. Reducer. In this time, I want to check about that average density of nitrogen dioxide. Use here EE dot reducer dot min. Then scale. Scale is that resolution. So this resolution is that 1113.2 meter. Okay, this is the resolution. I simply copy the resolution from here. Paste. And X property, we default is right here the system time start, because I want to make the chart according to my system time start. So use the system time start. So now this whole things I want to print. So just I write the code in one line. Did not take any types of other variable. If you want, you can also take the other variable and print the variable. It also okay. Just I simply use the print and start the parenthesis and also close the parenthesis. So now click to run. In this time, it generating the time series chart. We can get this type of time series chart. We can get okay, but in this time it's also another problem. This problem is that you can see it show the nitrogen number column density is the 0. Okay, but this time December 3rd December we find out the highest value of nitrogen dioxide density, but in this time it show the 0. You can see all of those value will be shown as a 0. You can see 0. Okay, you can see 0. All of them will show as a 0. This main problem is that this value is very less than 0. Okay, so that's why it show you the round figure as a 0. Suppose this value is the very less value, very negative. Suppose 10 inverse 14 or 10 inverse 15 or more than 10 inverse more value. So in this time this value is very small size. Okay, so that's why it shows the round figure as a 0. Okay, so but when you download this data in Excel file or CSV file, then we can get the accurate value. Suppose in this time, when I want to download the Excel file from here, suppose I download the CSV file, I get the CSV file value as a 0. You can see all of those value, it show as a 0. Okay, but for that, we can directly download the data as a time series CSV file. You can see it show the value as a 0, but it have a value about that mole per meter square, but this value is very less. So that's why it shows as a round figure 0. But when you download the data in Excel file or CSV file directly without create of chart, then it show the raw value about that. Okay, so that's why in this time I also show you that how we can easily download the Excel file or CSV file, because in this time the chart is look like 0. It did not provide any value, but it has a value. This value is the very less value. So that's why it show as a round figure 0. You can see all value show as a 0. Okay, so in this time you can see for the Dhaka city chart is coming. There is no problem. But I also try to make the chart for the Bangladesh. Suppose whole country boundary of Bangladesh. Then what happened? You can check. I simply import the Bangladesh shape file and put this name.
Hello,
Suppose, yeah, please.
I have a question.
Yeah, please.
In your code at the line 7, why we didn't use a key value like a dictionary?
Okay, so it's okay. So it's a totally different on you. Suppose we can get the 2 times, we can get the same result. Suppose this code,
Okay.
you can simply make the dictionary and put one by one keyword and key value, and also take the variable. Same process. Okay, but it's another way
Okay.
to write the code. Okay, same process. We can get the same result all time. Okay. So now I want to make this time series chart for the Bangladesh. I simply import the Bangladesh, and here against the AOI. I simply copy the AOI and change the region.
Hello.
Yeah, please.
So how can we get the dictionary just clicking one button, as I am new
Yeah.
in this field?
Yeah.
I always manually do this.
Okay. So for that, you can simply, suppose I write a function UI.
Yeah.
UI dot chart dot image dot series. Not this function, all of function. After make the parenthesis, your cursor, you can simply middle portion, and then press on your keyboard Control and space at the same time.
Okay.
Then all of this argument will be open, and from where you can make the dictionary, or you can simply put one by one. And when you want to put the without dictionary, you put the sequentially one by one value. Suppose I put the nitrogen dioxide and I put here the E reducer dot mean and then put here the AOI, then it will be not work. So when you put only for the value, you put sequentially one by one value put. Okay, Okay, and when we make the dictionary, then it also already define about that this is the keyword and this is the key value. Okay, so there is no problem. So there's a two-way using. If you want, you can also make the dictionary, or if you want, you can simply directly write the value only for the value. Okay, then it will be work. Okay, so now in this time here you can see when I change my boundary area, I put the Bangladesh boundary AOI, then it takes some time because it is a big area and there are a lot of images we can get for here for the big area, and so that's why it takes some time to starting or making the time series chart. And sometime it will show about that there are a lot of images, there are a lot of pixel value, so that's why it exceeds the memory limit and you can get the red alert sign, the chart is not generated. Okay, so for the big region, so basically when you want to work with the big region, then we face this type of problem, but in this time it will be work, there is no problem. You can see it's this chart mainly for the whole Bangladesh. Okay, between this time period only for the 12 days we can get. Suppose I simply put here that 1 month, suppose I put here the year of 2023, suppose 1st January to January, suppose 31. Okay, now check about that. And this way you can see it's also increased 426 images. And it takes some time to generate the chart because it's a big area. And sometimes when you want to work with the more big region, then it will be did not make the chart. So for that we have also need to make the CSV file. Suppose using the CSV, we directly download the data in Excel file, and then using this Excel file, we can easily make the time series chart. Okay, so now in this time, it also worked. Okay, so now in this time, I show you that how we can easily visualize the map. So visualizing the map, we are apply the same approach, which I show you already. Suppose I take a variable. In this time, I want to show the average density of nitrogen dioxide for the Bangladesh. Okay, so for that, just take a variable. Suppose average NO2, and then call the data set. This is the data set 426. I need to reduce it. So for that, and this 426 image is stored in this variable NO2. Simply copy and paste. And then if you want, you can use here the mean. There is the no problem. Or if you want, you can also use here the proper way. First of all, reduce. How I can reduce? Earth engine reducer dot mean. Okay, and then finally clip with your study area. So clip study area is that AOI. Okay, so now I simply show the layer. So map dot add layer of average NO2. We copy and paste, and also focus the center. Focus the center of the boundary shape file. This is RY or AOI, and put it at the suppose 9. Click to the run. So now it visualize for the whole country boundary. And this data set, suppose this data set, this resolution is that you can see 1130 by 2 meter. Okay, almost 1 kilometer. So that's why this data set is work well for that big region. Suppose when you want to work this data set for that only for the Dhaka city, then you did not get the proper pixel value. It also enlarged the pixel and it not show good. Okay, but when you want to use this data set for the big region such as whole country boundary of Bangladesh or India, then we can also get the better map using this data set, because this data set resolution is that 1113.2 meter. So in this time it shows this type of black color map. I want to add the color. So they already have some default color from here. Simply copy and then paste. So now here you can see mainly in this time they make a dictionary. In this dictionary they are including the mean value. It will be start from that 0 mole per meter square and max 0.002 mole per meter square. And then they also put here that color. Black is show about the low value, red is show about the high value of density. Simply copy. You can see in this time we can get this type of problem. Okay, user memory limit exists, so it cannot make the chart. Okay, so for that we have also need to use the CSV file. We directly download the CSV file of the time series data set, and we can easily make the all of those time series data. And from here, we can easily make the time series chart using the Excel file or CSV file. Okay, so you can face not only for that other data set. When you face this type of problem, then you try to download the time series data in CSV file without create of chart. Okay, so mainly this problem occurred when you want to work for the big region or lot of data set, it exceeds the memory limit, then this type of problem we face and it not make the generating the chart. Okay, so now I simply copy this variable name and paste here, and simply copy this variable and paste and click for run. So now it display this map. Now it show the map for the whole country boundary of Bangladesh, a nitrogen dioxide density map. Okay, so mainly this time you can see this type of red color identify about the high density. Okay, also you can see that high density. Okay, so basically in this time, the nitrogen dioxide, the main source of the nitrogen dioxide is that human activities such as the combustion of the fossil fuels such as coal, gas, and oil, especially fuel used in the car in this Dhaka city. So that's why in this time we can get here the high density of the nitrogen dioxide. Also you can get from here. Also you can see this region. Okay, it's the high density of the nitrogen dioxide for this region. So in this time we can get the nitrogen dioxide density map. And after that, suppose in this time I want to show you that, and you want to export this map, same process. Suppose just use here the export image to drive, and put all of those argument one by one and make a dictionary. And suppose image is this is the image, put at the description, same process. Okay, and when you face any problem, suppose it show about that max pixel value, it the exceeds the limit, then you put the max pixel value 1E13, then it will be work, and you can easily export this type of TP images. Okay, so using the same process, you can easily display the other types of data set which is available in here, such as carbon monoxide and also methane. So this type of gas, the same process for making the time series chart and also visualize the density map. So now we talk about that how we can easily make the CSV or directly download the CSV data. And in this time we can see it also show about that 0. Okay, but it have a value. This value is not show because it's very less. Okay, so that's why it ultimately it show as a round figure 0. But when you want to download the data in CSV file, then it automatically show about that the value in your Excel file or CSV file. So now we talk about that how we can download the data in Excel file or CSV file. Okay, so not only for this data, all of those data, when you want to download the time series data in Excel file or CSV file, just apply the same process. Okay, so in this time in your Excel file, we need to generate the two column. One column represented the time and another column represented the value. Okay, so for that we can make a function. In this function we define the two column. One column is represented the date or time, and another column represented the specific date, what is the value, show the value. So for that, just take a variable. Suppose I put the variable name is that CSV and create a function and put the element name, suppose img, and I want to make the dictionary. In this time my argument is that I need to create two column. One column represent about the value, another column represent about that date. I take a variable, suppose value. Okay, mainly this it stored the value, and this value calculating from this image. So I simply copy the element name image and paste here. And when you want to calculate the value, what is the function you need to use? We simply use at the reduce region function. Okay, so a lot of time we use the function for calculating for minimum, maximum, average. Okay, and for a specific boundary, we use at the reduce region function. And now simply import all of those things. First of all, reducer. In this time, suppose I just make a dictionary. So put here the curly bracket start and also curly bracket int. And now put all of those value one by one. Suppose reducer. So reducer in this time, ee dot reducer dot mean. Okay, I want to calculate, make the download the time series data mean value. Suppose you need the maximum value, use here the max. You need that minimum value, use here the mean. So geometry. Geometry is your shapefile variable name. In this time, I want to download the time series data for Bangladesh country boundary. Bangladesh country boundary is stored in the AOI. So just put here the AOI as a geometry. AOI. Then scale. Scale is the resolution of your satellite images. 1113.2 meter. And other things .NET simply. Okay. So now I take a variable, and this variable calculate the value. Okay. And now I take the another variable. So mainly this variable calculate extract the time. And this time is the same. Suppose in this time here you can see, I simply print this NO2. All of those images have a specific time or date. You can see all of those images we can get from here feature. All of those images has a time. Okay, and in this time I want to extract the time from here. So for that I just simply take a variable. This variable name is that I put the variable name, suppose date. Okay, and this date come from this same image, which image provide me the value, same image. So I use at the image and use at the date. Okay? And date is a number, but in the CSV file I want to count as a string. Okay, so that's why use at the format function. Mainly it's convert number to string. Okay, done. So in this time my first argument is that I create a variable. In this variable stored the image value, and this variable date, it stored the date for a specific image, specific date. Okay, so now further in this time I just create a dictionary using the value and date. So just take a variable and put here the variable. Suppose I put the date and make here this thing, suppose date. It's come from this date, same. And then also put here the value. It also come from this value. The same variable, same key value and keyword put in here and make the dictionary. And I return from this from here. So use here the return. I want to return from feature. ee dot feature. Put here the null and set with dictionary. So set, this is the dictionary. Simply copy this variable name and paste here. Okay, so basically this is the function when you want to extract any kind of time series data in CSV. All time, not only for this data set, any data set you want to extract the time series data set in CSV, just use the same function. In this time, this function you need to connect with your image collection. I already make the image collection, total 426 image collection we already generate. Okay, so in this time I need to connect this image collection in my function, and then it will be work. So in this time, how I can connect? We already know about that. We just need to use the map function, then it will be connect. So just take a variable. Suppose I put the variable name, suppose final CSV. Okay, then call my collection. So what is my collection? Collection is the NO2 because it stored a total of 426 images. So just simply copy and paste here, and then use the function map function, and then simply copy the CSV and paste here. So now it's connecting. Okay, so now I simply print that final CSV and click run. So now it makes a feature collection and also extract the all of those value for each date. Okay, so here you can see I can get this type of things from here. So here I can get the feature, and you can see here I can control 426 feature. Suppose I check in here, and here you can see that two properties. One is the date, another is the value. In this time I can get the null value. It means that for this time, basically it's the time wise data. Okay, so in this time you can see the time is that 9 hours 1 minute 24 second. This time there is a no value. So now also you can check the other data set. In this time all of those data we can get the time wise in this time, because it's provided. You can see this time 7 hours 17:26 this date. In this time we can get the value about that mole per meter square. Okay, so in this time suppose I want to extract all of those value in CSV. In this time we can get the sum value is that null. Suppose this value this time there is the no value. Suppose in this time you can see 5:35 minute 56 second. It extract the information mole per meter square. Also you can see this time there is the no value, so show about the null. Okay, so now I want to extract all of those things in CSV file.